Welcome to the presentation of our paper, Characteristics of High-Performance Value Streams. The paper was written at the Institute of Production Management, Technology and Machine Tools by Professor Joachim Metternich and Carsten Schaede, your presenting author. Customers demand individualized products at minimal lead times. In this example, an Asian supplier delivers individually designed printed circuit boards within a lead time of only 3 to 4 days. Individual solutions are provided to global customers within less than 1 week. While a typical engineer-to-order process consists of several time-consuming process steps and plenty of possible reasons for delays, the order fulfillment process of the individual printed circuit boards appears to consist of less process steps and a streamlined process sequence, resulting in a substantially shorter delivery time. We therefore named this concept of order fulfillment high-performance value stream. These high-performance value streams enable the production of individualized products starting at the quantity of 1 within minimal lead times at competitive cost and of course at the required quality. We wondered, what are the design principles underlying the concept? What are the main differences compared to engineer-to-order and assemble-to-order processes? How can the concept be applied to existing value streams of individualized products? And when does the concept pay off? Within this presentation, we'll look at existing concepts from the literature. I'll explain how we elaborated the presented results. I'll introduce 4 fundamental principles of high-performance value streams. We'll look at areas within the order fulfillment process where high-performance value streams differ from engineer-to-order processes, and the elements of the elaborated morphology for these areas. And finally, we'll look at characteristic types of high-performance value streams as well as their implementation. Within the literature, 3 main concepts are to be found that are related to high-performance value streams. First, co-creation, the integration of the customer to the product definition. Second, quick response manufacturing, the minimization of throughput time. Third, lean production, aiming at value streams that are free from waste. In cooperation with 18 companies, we analyzed 22 order fulfillment processes of individualized products. Thereby, we paid special attention to the flow of the order-specific information by applying the value stream mapping 4.0 method that was developed at our institute. In addition, we carried out interviews with 5 experts from the industry who have implemented or are managing value streams that contain successful elements for the fast supply of individual products. We thereby identified strategies and procedures of high-performance value streams that minimize process variation and lead time. Here are the 4 fundamental principles of high-performance value streams. First, limited product solution space. Through the definition of a limited product solution space, the variety of product and process is limited. Drivers of complexity are eliminated. Second, customer involvement. The phase of iterative adaptation development, which is time and cost intensive, is transferred to the customer. Therefore, a digital front end is implemented. Within this front end, the customer defines the individual product through development or adaptation. Third, automated generation of production data. Based on the limitation of the product solution space, the processing of the order can be simplified and drastically shortened. Knowledge-based tools enable an automated generation instead of a manual preparation process for production data. For example, CNC programs are generated automatically. Minimizing delivery time. All waiting times and process times that do not add value to the product are eliminated. The time between order and delivery of the product can be reduced to a minimum. The value stream therefore is not optimized in order to maximize capacity utilization. Instead, it is managed in order to achieve minimal throughput times. In which areas of the order fulfillment process do high-performance value streams particularly differ from engineer-to-order processes? It's the definition of a solution space, the process of product definition, the offer, order, and payment workflow, the production preparation and planning, the production process, and the shipping process. In the morphology presented within this paper, the differentiating features within these areas are explained. Here are some examples from the morphology. As mentioned before, the product solution space is closed. It is limited by both the restrictions resulting from the product and as well the restrictions from each step of the order fulfillment process. The process of product definition is performed by the customer. It can be a co-creation as well as a configuration process where the customer develops an individual product design or adapts an existing design to fit the individual needs of the case of application. The offer, order, and payment workflow is always fully automated. Offers are not created manually or released manually, so there is never a time delay that is caused by the supplier. The production process is capable and prepared for the entire product solution space. There is no individual clarification or time-consuming adjustment of the process for an individual product. We identified three characteristic types of high-performance value streams. These are type 1, the service approach to upgrade a product or system. The supplier offers individual supplies for an already sold investment good in minimal lead times to improve the operational capability of the product. An example is the company Trumpf offering its machine tool customers a web shop with an integrated design environment. Within this design environment, the customers design and order individual stamping tools for their machines. The tools are produced and delivered within 24 hours. Type 2. Individualized components as standalone products. Customers design or adapt components within the webshop of the supplier. The individually designed components are produced and supplied within a few days. An example is Mizumi, a Japanese company that delivers configurable mechanical components such as shafts or pins in a delivery time starting from 3 days. Type 3. Individual system design. In the adaptation process, complex products are designed or adapted according to the individual demand. The individually designed components of the product are produced in high-performance value streams, enabling an assembly of the individualized product within a few hours after product design. An example is the process chain implemented at the pump supplier Munch Chemiepumpen Pumps. The individual baseplate of the pump system is machined without causing any additional effort to adapt the manufacturing process to the individualized design. When does a high-performance value stream pay off? The engineer-to-order process has comparably low initial costs. The system is designed, and in an individual order fulfillment process, product and process are adapted to the individual demand of the customer. From a lean perspective, this effort to adapt the process and product can be considered as waste. In the high-performance value stream, the initial planning effort is much higher. The product solution space must be defined, the web-based front end must be implemented, and each process step must be prepared for the entire product solution space. But as a result, the effort and cost to adapt the process to an individual product is minimized. Besides sales effects due to fast deliveries, the concept pays off whenever the sum of saved effort to adapt product and process compensates the additional initial effort to implement a high-performance value stream. Short conclusion. High-performance value streams enable the production of individualized products starting at the quantity of 1, within minimal lead times and at comparative costs. Within our paper, the differentiating characteristics of the concept are presented. Our ongoing research is about cost models for profit and loss calculation, a decision tool for solution space definition, implementation procedures for the transformation from engineer to order to high-performance value streams, the transfer of the concept to additional fields of application, such as service and maintenance processes. Thank you very much.